So today we're going to look at polynomial long division, but before we look at long division with binomials and trinomials, we're going to look first at how long division looked with just numbers like questions A and B. So we're really focused on the process of long division and not necessarily how efficient we are in it, and thinking about kind of our four-step method for doing long division on paper. So if I'm doing something like 72 divided by 12, I put my divisor on the left side and my dividend on the inside, and I'm thinking how many times does 12 go into 72? So in this case it goes in 6 times, right? And then I do my multiplication, so 6 times 12 is 72. I subtract these two numbers and I'm left with 0. So 72 divided by 12 is 6. If we move to question B, we've got 254 divided by 3, so I'm going to set up my long division again. Now I'm thinking how many times does 3 go into 2? In this case it doesn't, so I've got to move over to the tens place, so how many times does 3 go into 25? The most that it can go in is 8 times. Now I do my multiplication, so 3 times 8 is 24. And I'm going to move on to my subtraction. So 25 minus 24 is 1. And then I have another number to bring down. So I'm going to bring down my 4 to make this 14. My process starts over again. So now I'm thinking how many times does 3 go into 14? Goes in 4 times here. Do my multiplication. 3 times 4 is 12. Do my subtraction. And I'm left with 2. And my last step here, 3 can't go into 2 evenly. So in this case, 2 becomes my remainder. And there's two different ways that we can write our remainder. We can typically write it as 84R2, or we can write it as 84 and 2/3. So we take our remainder and put it over our divisor. Okay. We also can do this with expressions like 8x squared. So if you look at question C, if I'm doing 2 divided by 8x squared, I'm thinking how many times does 2 go into 8? It goes in 4 times, and in order for this to work, I've got to put an x squared on it. So when I do my multiplication, I get 8x squared now. So now I can do my subtraction, and I'm left with 0. So 8x squared divided by 2 is 4x squared. So our main vocabulary when we're looking at long division is our 4 terms here. So the number that's being divided is called our dividend. In this example, our dividend is 10x squared. The number that we're dividing by is called our divisor. In this case, it is 3. If we have a term that's left remaining and we can't divide it anymore, we call that our remainder. And then our number that goes on top of our long division, or what's left over, is called our quotient. We can also check a quotient to make sure that our division was done correctly. So we can do our quotient times our divisor plus our remainder is going to equal our dividend. So if we check it with this, we know 3x squared times 3 plus the remainder of 1x squared is equal to our dividend of 10x squared, and this is a true statement. Two ways that you can write a quotient. You can do a quotient comma remainder. So in this case, if we use this example, we could say that our quotient is 3x squared with a remainder of 1x squared. We can also write it as a polynomial expression. So this is where you write the quotient and then you add it as that fraction like we talked about in the first example. So this would be an x squared over 3, because 3 is my divisor and x squared is my remainder. So before we move to our long division examples, there's kind of 4 reminders that we need to keep in mind as we divide. Polynomials have to be in standard form in order for our long division to be done correctly. Standard form, again, is where you go from the highest degree to the lowest degree, or the highest to lowest power of x. Our second reminder is that all terms must be included. So if you have a polynomial that starts with x to the fourth but doesn't have an x cubed term, we still have to add in that x cubed term in order for our long division to work. Okay. So an example of this, let's say my polynomial to start is x to the fourth minus 2x squared plus 3. If I was using this polynomial for long division, I would have to write in my missing term. So I would keep my x to the fourth. I'm missing the x cubed term, so I'm going to put a placeholder in. I've got my x squared term. I'm missing an x term, so I'm going to add in that filler. And then I have my constant at the end. Our third reminder, we're going to repeat this process of dividing, multiplying, and subtracting until no more division can be made. So that goes back to our warm-up problem where you're dividing, multiplying, subtracting, bringing down the next term, and then that process starts over. We're going to use that same process as we start to divide polynomials. And then fourth reminder, we want to place each term in the quotient directly above its counterpart. That's just so our work stays aligned and we know that the degree of our quotient is always one less than the degree of our dividend.